This is the screencast for section 4.4, example 5. We're going to combine a phase shift, which is a horizontal shift left to right, with a period change, so a horizontal stretch or shrink. There might also be an amplitude change, which would be a vertical stretch or shrink as well. So we're going to construct a sinusoid with period pi over 5 and amplitude 6 that goes through the point 2, 0. Well, I'm going to start with the easiest and work my way up from there. First, I think the easiest change to manipulate in a sinusoid is the amplitude. If the amplitude is 6, this sinusoid is going to stretch from -6 to +6. So half the height of its wave is 6, which means the a value out in front is 6. So far we have 6 sine of x. That's got an amplitude of 6. Now we need to change the period to pi over 5. Okay, so the period is 2 pi times the reciprocal of the coefficient of x. So 2 pi times 1 over some sort of number is going to be pi over 5. Now that's how your book also gets the formula for the period of 2 pi over b. Same thing. So if let's see, I don't know, what do you want to do first? Let's multiply both sides by b first. And then I get 2 pi equals pi over 5b. And now I'm going to multiply by the reciprocal of pi over 5, so 5 over pi to both sides. So I get b equals, let's see, those are going to cancel, so that's 10. b equals 10. So now I have y equals 6 times the sine of 10x. Alright, well now I've got to find out a way to make this curve specifically pass through the point 2, 0. Well, if it passes through the point 2, 0, I know the sine of 0 is 0. So I've got to create an inside function, an inside expression that when I plug in 2, I get out 0. Well, that is 6 times the sine of 10 times not just x anymore, but x minus 2. So now what happens is if I plug in positive 2, 2 minus 2 is 0, 10 times 0 is 0, the sine of 0 is 0, 6 times 0 is 0, so when I plugged in 2, my overall value would be 0. So now this sinusoid function follows all the rules. It has a period of pi over 5, it has an amplitude of 6, and it passes through the point 2, 0. So let's make sure that's true on our calculator, but we're going to check the window really quick here. So the period of this function is pi over 5. So I don't need to set my window all the way out to -2 pi or all the way up to +2 pi. I could do negative pi over 5 to positive pi over 5 if I want to. So negative pi over 5 and then positive pi over 5. Now I'm going to scale my x-axis by pi over 5 just to see what happens for a length of the period, to make sure this curve repeats itself out to that end. You can change it to whatever you want though, really. The y minimum, well, my amplitude here is 6, so let's see. If I'm going to see from -6 to 6, maybe I want to go -8 to +8. So now I have two periods of the function, one right here and one right there. Let's see, does it pass through the point 2, 0? So I hit trace 2. Well, I get an error, and if I go back to trace on my graph, I can see that's because my x values are way too small. So I'm going to try to see if it passes through the point 2, 0 a different way. I'm going to tell my calculator to take the function in y1 and plug in the point 2. And I get 0. So I can see that the period is pi over 5. The amplitude is 6, meaning if I graph this, the height of this curve should be 6, and my y scales go by 1. So 1, 2, 3, 4, 5, 6. Yep, it goes all the way up to 6, so that's good. So it passes all of the rules it was supposed to. So I found a correct sinusoid that has the period of pi over 5, an amplitude of 6, and goes through the point 2, 0. Let's try the now try problem number 59. This one's got an amplitude of 1.5, a period of pi over 6, and passes through the point 1, 0. So the amplitude of this curve is 1.5, so now instead of y equals sine of x, it's going to be 1.5 sine of x. Since the period is pi over 6, that means 2 pi times the reciprocal of this number that goes in front of x is going to be pi over 6. So if I solve for b on both sides, I have, let's see, 2 pi, oh that's purple, meant to go green. 2 pi equals pi over 6 times b, multiplied by the reciprocal of pi over 6, which is 6 over pi. The pi's cancel, so I get 12 equals b. So now I have y equals 1.5 times the sine of 12x, but I've got to make sure that this curve passes through the point 1, 0. So I should be taking the sine of 0. Well, 12 times 0 is 0, so I'm going to say this is y equals 1.5 sine of 12 times x minus 1. So instead of just plugging in the number for x, I'm going to plug it into x, subtract 1 first, which would have, if I plug in 1, is 0. 12 times 0 is 0. The sine of 0 is 0. 1.5 times 0 is 0. So this function will pass through the point 1, 0, has a period of pi over 6, and has an amplitude of 1.5. Now, of course, on both of these functions, you might see them on a multiple choice written like so. 12x minus 12, so I'm just distributing the 12. Or on this first one, you might see y equals 6 times the sine of 10x minus 20.